Hello student, welcome to the course of Power Generation System. In our last lecture we have studied the constituent of hydroelectric power plant, that is the hydraulic structure. Today we are going to study its next important components, that is the water turbines. In water turbine we have two types, that is impulse turbine and reaction turbines. So water turbines are used in hydroelectric power station to convert the energy of falling water into mechanical energy. And we have two important parts, or two major parts of turbine, that is impulse turbine and reaction turbine. So mainly the falling water have energy, and this energy is converted into mechanical energy by using turbines. And we know that these turbines are coupled with the alternator that convert this mechanical energy into electrical energy. So let's see first one, that is impulse turbine. Impulse turbine are such a turbines that are used for high head, mean if the head is high. In impulse turbine the entire pressure of water is converted into kinetic energy in a nozzle, and the velocity of the jet drives the wheel. The example of this type of turbine is the Pelton Wheel. We have a diagram of a Pelton Wheel. This is the turbine, and we have the operating head, and here is the nozzle in which the water pass and hit these buckets, and by doing so it will rotate in a directions that may be clockwise or anti-clockwise. So this impulse turbine are used for high head, and the entire pressure of water is converted into kinetic energy in a nozzle, and the velocity of the jet drives the wheel. So an impulse turbine consists of a wheel fitted with elliptical buckets along its peripheries. The force of water jet striking the buckets on the wheel drives the turbine, and the quantity of water jet falling on the turbine is controlled by means of needles. So this is the diagram. We have elliptical bucket on the peripheries of the wheels, and we have the nozzles, and we have the needles which control the flow of water. The needle is placed in the tip of the nozzle. Now why we place this needle in the tip of the nozzle? Its function is the movement of the needle is controlled by the governor. If we have high load or less load, we can increase or decrease the flow of water with the help of this needle. So suppose if the load on turbine decreases, the governor push the needle into the nozzle, thereby reducing the quantity of water striking the buckets. So the quantity is decreased because the load on turbine is decreased. And if suppose the load on turbine increase, the governor will give the message to the needle, and therefore increase the quantity of water striking the buckets. So in this way the needle and governor, or the needle is controlled by the governor, and increase or decrease in the turbine load The needle will push further or back with the help of the governor, and in this way the reducing or increasing the quantity of water striking the bucket will occur. So this is the function of the needles in the turbine, that is the impulse turbine. This is another comparison of impulse turbine and reaction turbine. We have two basic types of turbines. There is the impulse turbine and reaction turbine. We have a fixed nozzle in impulse turbine and a moving nozzle in reaction turbine. This is the runner of the reaction turbine, and this is the runner of the impulse turbine. We have a buckets, and there is no such a buckets in this periphery. So this is the basic difference between the two. And now let us see how a reaction turbine work. Reaction turbine are used for low and medium head. As we see that the impulse turbine are used for high head, so reaction turbines are used for low and medium head. In reaction turbine, water enter the runner partially with the pressure energy and partial with the velocity head. The important type of reaction turbine are it has types. The first one is the Francis turbine, which is used for low to medium head, and it consists of an outer ring of stationary guided blade fixed to the turbine casing and an inner ring of rotating blade forming the runner. The guide blades control the flow of water to the turbines. So this is how a Francis turbine is made. It is used for low to medium head, and it consists of an outer ring of stationary guide blade fixed to the turbine casing and an inner ring of rotating blade forming the runner. Water flow radially inwards and change to a downward direction while passing through the runner. So in this way the water flow, as the water passes over the rotating blades of the runner, both pressure and velocity of water are reduced. This causes a reaction force which drives the turbines. So as we know that in reaction turbine, water enter the runner partially with the pressure energy and partially with the head. Because of head, it has some velocity. The next one is Kaplan turbine, that is used for low head and large quantities of water. If we have the amount of water is large and the head is low, we use Kaplan turbine. It is similar to the Francis turbine, except that the runner of Kaplan turbine receives water axially. There we receive water radially inward, and here it receives water on axis axially. So this is the two types of the reaction turbine. There are two basic major types of the turbine, that are the reaction turbine and impulse turbine, and we have a runner. On impulse turbine we have a fixed nozzle, and in reaction turbine we have a moving nozzle. Water flow in the Kaplan turbine, the water flow radially inward through regulating gates all around the site, changing direction in the runner to axial flow. This causes a reaction force, and in this way the turbine turns. So this is the types of the turbines used in hydro power station. These we first studied the constituent of hydroelectric power plant. The first one we studied in our last lecture was the hydraulic structure, in which we studied the different types of the hydraulic structure. The different components, there are the spillways, penstock, surge tank, etc. Then today we studied its other important part, that is the water turbines. It has two major or important types. The next one in the constituent of hydroelectric power plant is the electrical equipments or electrical component used in hydroelectric power station that are very similar, that are used in the steam generating station, which we already have studied. So that's all for today about the turbine. Thanks.